Okay, this is going to be a little intense. Before, a lot of the questions I was showing you, you could have more easily done with a loop, and faster too. I'm going to show you some questions that are well suited for recursion, but they require a lot of practice before you can do this easily. But I want to show it to you so we can start working towards that. This is a little intense. This is beyond AP. But the AP level is a bit of a happy medium between recursion 1 and recursion 2. So let's take a look at recursion 2. So first we have to understand the problem. We have this group sum 5, which is saying, hey, if I've got an array of integers, is it possible to choose a group of some of the integers such that the group sums to the target? You're given a target you're trying to sum to, but all multiples of 5 must be included in the group. And if there is a value 1 immediately after a 5, it must not be chosen. So not adding to your total. So let's talk. Here's how I did it. I have 2 base cases here. So if my start is greater than or equal to nums.length, and my target equals 0, because how I'm doing this is when I include my group, or when I check a number, I will reduce the target. That's the easiest way to check. So if I had another thing here, I could have my current running total and check that it equaled target, but instead, for every value, I'm going to see what happens if I reduce my target by that amount, or I don't reduce the target by that amount. Can I get to the total? Basically, my code will try all allowed possible combinations. Anyway, so if I get to the top and I've managed to subtract numbers in such a way that my target is 0, I'm going to return true. But if I reach that same point and my target was not 0, I'm going to return false. And here's how if I'm not at the end, here's how I go. So if the current number I'm looking at the current index I'm looking at, is divisible by 5, I guess all multiples of 5, yeah, all multiples of 5. So if I see a multiple of 5, I have to include that. So, but I also have to check if the next one's a 1. So here's my guard. So if I'm not going to go off the edge of the array, if I check the next number and the next number is a 1, I'm going to skip 2 numbers. I'm going to make my index skip 2. I will include the 5 because I have to. So I'm going to reduce my target by this multiple of 5. And of course, I'm passing my nums array because I will always pass my nums array. And if that works out, I will return true. Otherwise, if the next number is not a 1, then I will just check that I'll just keep going as normal. I'll check the same number as normal. So I just move up my index by 1 and pass the numbers array. But again, I just saw 5, so I must do the target, subtract the number by the multiple of 5. And if all that works out, if this is trues all the way through, if it'll eventually hit the base case, hit true, it'll return true all the way through, and my final answer will be true. Otherwise, if it wasn't a multiple of 5 that I was currently looking at, and it wasn't any of my base cases, I'm just going to try both options. If it's not a multiple of 5 and it wasn't just a 1 or after a 5, I can include the number in my total, which I effectively do by subtracting it from my target, or I cannot. I can just keep my target the same. And so I'll just ignore that number. Don't include it in the groups that are supposed to sum to the target. And then if I get to all of this and nothing has returned true, none of my possible options, none of the things I've been exploring, none of them return true, I will return false. And so this is one way to solve it. I could probably simplify it a bit, but yeah, that's one way of dealing with this complicated problem. Think her through a bit, especially this whole if statements right here. Because basically it tries all possible options. So hey, if it's a 5, does it work? With the 5, your hands are kind of tied. Basically, if it's a multiple of 5, you have to include the number. But otherwise, like if it's not a multiple of 5, you're like, hey, does it work if I include the number? Or does it work if I don't? Either way, if it worked either way, I will return true because there exists some group of numbers that can sum to the target. And this is just a good way to make things propagate through nicely. A whole bunch of if statements that return true, and then a returning false if none of them end up being true. All right, I'll try one more that's a little bit different. This one I made a helper method because it was quite challenging to do otherwise. But it simplified my code a lot. So in this guy, if I have an array of integers, is it possible to divide the integers into 2 groups so that the sum of the 2 groups is the same? So can I split it either, I called it left group and right group. All multiples of 5 must be in one group. I think I made that the left group. Yes. Yeah. And all multiples of 3 have to be in the other group. So there we go. So my method just returns the helper method, which has more numbers to keep track of everything. So hey, if you give me an array, I'll say, hey, I'm starting at my first index and my current totals of the 2 groups are 0 and 0. So this is the index I'm currently looking at, and this is my current running totals for the left group, which needs to hold the 5s, and my right group, which needs to include the 3s. I guess I made my, yeah. All right, so if I manage to get through everything, my index is going up by 1 each time. If I get to the end, I'm just going to return left equals right. So here's kind of my base case. If I hit the end, if index is my array's length, I check that my left group equals my right group. If it does, I return true. And otherwise, if I'm not on my base case, if a number is not a 3, I check, hey, what happens if I put the number in the left group and keep the right group the same and increase my index by 1. Otherwise, I'm like, hey, as long as it's not a 5, it can go in the right group. And then I check, hey, what happens if I tried to include that particular number I was looking at in the right group and increase my index by 1. And the propagating logic of this just makes it all work pretty awesomely. It will take some thinking to go through. I would try it with some random array and just walk your way through. Maybe let's do this guy just for fun. So to start off with, we're starting at index 0 and our left and right groups don't have anything in them yet. We haven't hit our base case. Our index is 0. It's not 3. So we're not going to do this guy. It's not a 3. So we're going to attempt to throw it the 2 into the left group. So the left group now holds 2 and the right group still 0. And then we're looking at the next thing. And we would also try throwing it in the right group. There'll be multiple cases where we'll return true. I'll just keep doing the one where it was in the left group because this branches kind of wildly. And then we go again. Our index is now 1. Our left group is holding 2. We haven't hit the end of the array. Our index is just 1. And so we check, hey, is 4 a multiple of 3, and does it work if we included the 4 in the left side? Of course it wouldn't, because then our left side would be 6, and we only have another 2 to add to the right side. So this will end up false in the long term, and so this doesn't happen. But with this, what if we threw in the 4 in the right category, the right group? Now our left group has a total of 2, and our right group has a total of 4. And then we try it with the next index. So index is now 2. And so we go here. We haven't hit our base case yet. Our index doesn't equal 3 yet. And so we check to see if we can throw that 2 at index 3 into the left group. So we're like, hey, what happens? It's not a 2's not a 3. What happens if we throw that 2 into the left group and leave the right the same? Well, if we do that, at this point, our left group equals 4 and our right group equals 4. It goes back to here where left equals 4, right equals 4, and index is 1 bigger. Index is 3 now, so index is equal to nums.length. It's equal to the length of this. And we check, hey, is left equal to right? Which it is. And so it will return true. So this becomes true, that returns true, and then it propagates back, which is kind of wild. Think it through, but the end result is the first time it hit this when we were checking to see if we could add 2 to the left group. This ends up returning true, and so it returns true to here. This ends up being true, so the whole thing returns true. Yeah. Anyway, this will take some thinking. This is more intense than you generally need for the AP exam, but it's good tricks. Anyway, thanks for listening and be well.